Now, when we create items, we have to place them somewhere on the screen, so that's what we're going to focus on today. Today, we're going to talk about the various ways that we can place the items within our application. This is going to include positioners, anchors, absolute or dead reckoning placement. We will also cover the use of layouts in QML. Now, anchors are by far going to be one of the ones that are used most often when it comes to creating interfaces that are adaptable. This is going to allow us to create an interface where we can target multiple screen sizes. And QML layouts can be really, really useful if we're trying to target multiple languages, since our strings can extend beyond the GUI elements. And of course, each one of these positioning methods does have some trade-offs. Now, when we place the items on the screen, we have a couple options to choose from. We can do it manually, where we set a fixed X, Y, width, and height for each of our objects. Or we can set anchors for each of our items relative to a parent or sibling. We can also use one of several container types that will place the items for us. Another option is we can use layouts, or we can use some combination of the four of these. Each of these methods has a valid use, and knowing when to use each one is important. First, I want to talk about the simplest, which is going to be manually placing our items by setting their X, Y, width, and height. In our example here, we've created our rectangle A. This has a height of 50 and a width of 70. It is at the coordinate 0, 0. This value will never change. That's fixed. Our rectangle A will always be at 0, 0. It will always have a height of 50 and a width of 70. The same is true for our rectangle B. It will always be at coordinate 0, 100, and it will always have a height and a width twice that of rectangle A's. This will be true even if we resize the item or the container that this is inside of. Now, dead reckoning, we should avoid using whenever possible. Sometimes, however, it is our only option. And this tends to be the case if we need pixel perfect layouts, or if we have full control over the dimension of our objects and the screen resolution of our target is not going to change. There are some pros and cons. Now, these dead reckonings layouts can be made to resize correctly by adding bindings, and the bindings make it more declarative, of course. There are some downsides to this. The binding recalculations can get expensive as our interface becomes more complex. And since the bindings are going to also create some cascading bindings, those are going to create intermediate stage, which means we're going to get additional bindings. And every time we have more bindings, it's going to have more recalculations. So this can get costly. Now, looking at this simple example here, this screen has about 40 items on it. Each of these items requires 2 binding calculations. And here's where we can start to see how dead reckoning isn't really ideal if we want things to resize. A resize here is going to trigger at least 80 recalculations for these bindings. Now, that doesn't count any intermediate states that happen while the bindings are being recalculated. So again, dead reckoning is really, really only used if we're intending to target multiple, only one screen size with a specific resolution. Now, we're going to look at a more less costly and more commonly used method called anchors. Anchors are going to be your preferred way to place your objects for most situations. Now, anchors don't use numbers. They use the enums shown on the right side here. These enums, they specify a wall or anchor point that we can reference when we're attaching another item's wall or anchor point to it. It's also important to note that anchors can only be attached to items that are parents or siblings of the item. Here, we are anchoring our text label's right-hand side to our parent's right side. Notice how we're using anchors.right to get a reference to the text label's right anchor, and we use parent.right to get a reference to the parent's right anchor. The QML line anchors.right:parent.right is setting the text label's right anchor to be the same as the parent's right anchor. We do not use for this parent.anchors.right. That will not return the anchor value for us. Now, anchors also have margins. These margins are specified in pixels, and they allow us to define some spacing between the target and an anchored item. The margins are top margin, right margin, bottom margin, and left margin. And they provide spacing respective to the anchor that their name suggests. For instance, our top margin provides a margin value for the top anchor. Here's another example. We are we're anchoring our image's left anchor to the parent's left anchor and assigning a little bit of spacing. We're also centering our image vertically in the parent by setting anchors.vertical center. Now, if we look at the text item, we see this anchors.baseline. This is another anchor that we have that corresponds to the imaginary line on which the text will sit. Here, we're anchoring that text's baseline to the book's vertical center. So in other words, the text will sit along the vertical center of the book. There are some special anchors that are going to allow us to set multiple anchors at once. And these are really handy if we want to fill or center an item within another item. For the first case, if we want to have item B completely fill item A, we would have to set a top, bottom, left, and right anchor for item B to be equal to those of item A's. Now, we can remove the need to do this by using the anchor fill. We simply tell item B to fill item A by writing anchors.fill : item A. The anchors.fill is going to take the ID of the item that you want to fill. Now, the same applies if we're going to try to center item B in item A. Normally, without using anchors.centerIn, we would want to set the horizontal and vertical center of item B to be the same as item A. But we can instead use centerIn, and we can do this by simply telling item B to be centered in item A by writing anchors.centerIn : item A. Just like the fill anchor, the center in is also going to take an ID of the item that you want to center in. Now, with these complex anchors, the rule that the target must still be a parent or sibling still applies here. Now, let's look at this example here. We have a rectangle with a text child. The text child is being centered in the rectangle, and we can make use of the keyword parent instead of rectangle 1, since the text label is a child of rectangle 1. Now, of course, we still could have anchored to anchor center in rectangle 1, and that would have worked. As I previously mentioned, writing anchors.centerIn is exactly the same as setting both of the center anchors, anchors.horizontal center and anchors.vertical center. Here is an example using the anchors fill. Similar to the previous example, and we are using parent instead of the ID of the actual rectangle. Now, the fill anchor is applied to the red rectangle, and the anchored item assigned is the parent, which means that our red rectangle is going to fill our parent item. Now, as shown here, this is the same as setting our left, right, top, and bottom anchors of our rectangle to those of the parent. A useful strategy for anchoring requires that you identify what items on your interface are going to be fixed items and which items are going to be dominating. Our fixed items are going to be items that won't resize or change their position, even if their parent or siblings change. And the dominating items are going to be ones that influence other items to resize or change their position. When we break our items up into these two different groups, it helps us identify what items we're able to anchor and to what. For instance, if we decide that rectangle A is going to be a dominating item, we want to have our other non-dominating items resize based on rectangle A by setting their anchors to be equal to rectangle A's. Again, both our fixed and dominating items are going to need ID properties. And of course, you can use the parent keyword to reference them. Now, it's important to remember that our anchors can only be used with parents or siblings, and something is going to need a well-defined position and size. Anything that doesn't should be anchored to something that does. Now, when we create anchors between objects, we are creating dependencies on those objects' geometries. So it's important to try to avoid creating any circular dependencies where the parent is going to rely on the child and the child has to rely on the parent. And it's also good to remember that if you make margins, they only work if you attach the corresponding anchor. So if you set a value for your left margin, unless you set the left anchor, the left margin won't do anything.
Thanks for watching. If you want to learn more, please subscribe to our channel and check out the free QML programming course on our website. The link is in the description.